You are right to worry that no one at your company actually knows where your personal identifiable information lives. This is not a hypothetical compliance issue or a theoretical risk on a checklist. It is a critical vulnerability that exposes your organization to massive regulatory fines and model poisoning attacks. By the end of this video, you will understand a code-first strategy that automates the discovery of this hidden data and transforms your scattered engineering pipelines into a governed, secure environment. The Federal Trade Commission calls this the take stock principle, and it highlights a terrifying reality. Personal data is not just sitting in a central database. It is scattered across laptops, cloud services, home devices, and legacy file systems in formats that manual audits simply cannot capture. If you rely on a spreadsheet or a quarterly review to find your sensitive data, you are already behind the curve. The sheer volume of unstructured files, from CSVs to Stata and SAS datasets, creates a shadow IT landscape where engineers unknowingly train models on sensitive customer records. This is where most engineering teams fail. They build modern data lakes and assume that because they have a centralized architecture, they have visibility. But the real danger lies in the unstructured legacy files and non-centralized databases that sit outside your main data lake. These are the sources where PII hides. When you try to train a machine learning model, you might pull data from a forgotten CSV file on a developer's laptop, and suddenly you have exposed sensitive information. The failure mode is not a lack of tools. It is a lack of automated discovery that can traverse these disparate systems programmatically. To solve this, we need to move beyond theoretical checklists and adopt a code-first approach. Open-source tools like pSpider demonstrate that we can operationalize the take stock requirement by writing code that automatically traverses databases and file systems. The concept is straightforward. You provide simple connection credentials, and the tool scans database tables to generate comprehensive reports. This replaces the manual audit with an automated inventory that runs every time you change a schema or add a new data source. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. However, we must be realistic about the trade-offs involved in adopting such tools. The current landscape is not perfect. While tools like pSpider can detect PII using static pattern matching for emails and social security numbers, they also need semantic analysis of column names. This is crucial because legacy schemas often lack obvious indicators. A column might be named col42, but actually contain customer addresses. Without context-aware scanning, you get noisy inventories filled with false positives that require manual validation. Here is the hard truth about production adoption. Many automated scanning tools are still experimental. The remote control daemon in some popular open-source projects is explicitly labeled as experimental with no production safeguards. This means you cannot simply plug it into a high-volume enterprise pipeline without careful consideration. You also face integration friction if your team relies on standard Python or Java stacks, as some of these tools are built in languages like Racket that do not fit your existing ecosystem. Furthermore, discovery is only half the battle. These tools answer the question of where the data is, but they do not inherently address who has access to it or how to control it. There is a significant gap between discovering a field and enforcing a policy that restricts access to it. Without automated tagging, you are left with a list of flagged fields that you must manually classify and tag. This manual burden can slow down the transition from discovery to protection, leaving your data vulnerable for days or weeks after you find it. The most valuable insight you can take from this is that automated scanning is a necessary first step, but it is an incomplete strategy on its own. You need a pipeline that transforms PII from a theoretical compliance risk into a tangible data quality metric. This means implementing an auto-tagging system that enforces guardrails at the ingestion layer. When data enters your system, it gets tagged automatically. This allows you to prevent sensitive data from ever reaching a model training environment, rather than trying to retroactively secure unknown data stores after the fact. Consider the alternative. If you rely on simple regex matching for every field, you will generate a noisy inventory that requires hours of manual review. You might flag thousands of fields, most of which are not actually sensitive. This creates engineering overhead that teams cannot sustain. Context-aware scanning reduces this overhead by understanding the semantic meaning of your data. It looks at the column name, the surrounding context, and the data patterns to make a determination. This reduces the number of false positives and allows your team to focus on the fields that actually matter. The goal is to build a system where the discovery process is continuous. Every time a new table is created or a new file is uploaded, the system scans it, tags it, and applies the appropriate policies. This shifts the burden from the security team to the engineering team in a way that is automated and invisible. Engineers do not need to think about compliance every time they write a query. The system handles it in the background, ensuring that sensitive data is never exposed. This approach requires a hybrid strategy. You combine static pattern matching with semantic analysis to catch sensitive data in legacy schemas. You prioritize scanning unstructured files that are often ignored by modern data lake architectures. And you build an automated tagging pipeline that turns discovery into a governance mechanism. This is how you move from a state of fear and uncertainty to a state of confidence and control. The stakes are too high to ignore. Regulatory fines for data breaches are increasing, and the cost of model poisoning can destroy a company's reputation. But the solution is not more manual audits or theoretical checklists. The solution is code that runs automatically, scanning your infrastructure and tagging your data in real time. By implementing this strategy, you ensure that you know exactly where your personal information lives and that you have the controls in place to protect it. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.